Welcome to the Cosmic Pie Podcast, Episode 8, Season 4. I'm your host, Wayne Barkhouse.
And I'm Robert Moore, sort of.
Robert's not feeling well today, so as you'll recognize from his voice, as you'll see. I will introduce our guests in a second here, but I just wanted to make sure that you're aware we are broadcasting live from the campus of the University of North Dakota here in Grand Forks, North Dakota. We do have a live chat feature that is running, so if you have any comments or questions that you'd like to send us during the podcast, feel free to use that. And if you like this podcast, don't forget to give us a thumbs up. That's what everybody says nowadays, right, Robert?
Right. Thumbs up.
And also subscribe if you haven't subscribed. And also don't forget we do upload our podcast the next day on Spotify if you'd rather listen to us on that. And as a disclaimer, since Robert's not feeling well, I will do that. Anything that Robert and I or our guest says is our own personal opinions and not necessarily the opinions of the Department of Physics and Astrophysics, nor the College of Arts and Sciences, nor the University of North Dakota, nor the United States government, nor the world government, planet Earth, the universe. How's that? That covers everything.
Whoops. I messed up. There we go.
Okay. So today we greatly appreciate the fact that we have a really great guest, and that guest is Dr. Space from the Space Show, Dr. David Livingston. So thank you very much, David, for connecting with us.
Good to be here. Thank you very much for the invitation.
Now, as a short intro of your background, I went through your CV just before, like a CIA spy, and I noticed that you have a BA at the University of Arizona in political science. So we can get into a little bit of politics here coming up related to the space program. You also have an MBA from Golden Gate University and also a doctorate in business administration from the same institution.
Correct.
Now, David, everybody's focused on Artemis 2, and the latest that I've heard is it's going to be rolled back as yet another delay starting tomorrow. So now the schedule is to launch humans to the moon, first time since 1972 with Apollo 17, probably, if we're lucky, in early April. Now, David, there's been a lot of controversy over the last several years. I think it goes way back even before the Obama administration, the first one, where people had suggested that maybe it's the time that NASA should get out of this business of sending humans to destinations like the moon or Mars, and maybe they should be concentrating, such as maybe the advancement of propulsion, nuclear rockets and whatever, comes down the pike later on, that we should really leave it up to businesses like SpaceX, like Blue Origin, or any other, company that comes along. What's your feeling in all of that?
Well, I'm not sure they should get out of the human space business. They have been a leader in it. Their development of space medicine requirements for being in space is far more capable than what the private sector can do or has shown to be able to do. And I think that space medicine and the human factors, as it's called, side is really worth discussing. But I think the biggest objection is they should buy the ride, so to speak, from the private sector. And so therefore the rockets and the launchers would be private, and they would contract for the ride to whatever the mission might be or the destination might be. That's on the surface sounds like a really great idea, but if we look at the vehicles available for the ride, you basically have Falcon 9 and Falcon Heavy that can get to the space station. Maybe Falcon Heavy can be engineered to possibly get to the surface of the moon. Maybe. I'm not 100% sure on that. But Starship still doesn't fly, and New Glenn is behind and it doesn't fly. And Rocket Lab's a great company, but they're building smaller rockets. So there is no private ride for human missions. So if NASA really does want to go to Mars someday, or wants to have a human mission to some other place, there just aren't any rockets. So the question would be, what about the government rockets? Well, The problem with SLS is it can't go anywhere, and it costs a fortune to launch and service. And its flight rate is so miserable that you have to have, which is almost non-existent, by the way, you have to have a standing army that is experienced and knows how to fly that rocket and prepare it to fly, and all of that kind of stuff. So just the whole idea that SLS has to roll out for however long it takes to get to the launch pad at the Cape from the days of the Apollo days is really something, because you can look at what SpaceX does to put a Falcon Heavy ready for launch, or even to test fly their components of Starship. So I think the idea to get rid of SLS is probably a pretty good idea, except there's really no option. So we got rid of the space shuttle, and there was no option. We ended up having to buy our rides and contract with the Soviet Union, with Russia, and we had to have an exception in Congress to do that, because everything else that Russia was doing, we were on the opposite side of the fence and not supposed to be doing business with them. So we had a special law that said we can fly to space with them. Otherwise, we would not have gotten any astronauts or personnel to the space station, because the only people flying were the Russians. So you don't really want to cancel your only ride to space beyond the space station, so we can get to the space station. But SLS is a problematic rocket. It's had the big successful inaugural flight. It can't make it to the moon on its own, which is why the Artemis program has a gateway program involved in it. And it can make it to the gateway, but that's it. Then you need a lander to go to the surface of the moon, and we don't have a lander for that. So both Blue Origin and SpaceX, with their various lander designs, are behind the eight ball on that too. Although I think they're trying to beef up their work on it in order to make these deadlines of getting to the moon in 2028 before China perhaps gets to the moon. And by the way, I do think that it is important to get back to the moon before China gets to the moon. I guess we can discuss that later on. But SLS is a difficult product, and it's got two launch windows for the moon in April, the first of the month and the end of the month. And if they don't find a way to fix this liquid hydrogen leak, they're not going to fly. So NASA's really sensitive about that. They do remember the Challenger accident, right, and they do remember the more recent accident, and they don't want another one, especially with these 4 people on board that are going to be the crew looping around the moon. So hopefully it will fly in April, and it will be safe. The weather is going to warm up, so cold weather and liquid hydrogen don't always mix. So I'm not surprised they're getting hydrogen leaks. So hopefully they will be able to fly and fly safely, and it will be a successful flight. We could discuss on whether it's the really big, impressive, wonderful flight that the media makes it out to be. I sort of have my doubts about that. But maybe that's worth talking about. I don't know that the general public is going to embrace this as the biggest moment of the decade.
Now, it's interesting, and Dave, when you listen to the astronauts just before they went in quarantine for the first time, saying, they're joking around, stating, at some point we're going to have Artemis 100. But given the duty cycle, if you like, of launches, that could be in 300 years or so from now, when you think about it. And the other thing is, if you're a space enthusiast, anybody out there who's listening, as I am, somebody that at a young age, wanted to see NASA, because NASA was the only really game in town besides the Soviet Union at the time. You wanted to see NASA do all, like we've done in Antarctica, from my point of view, is to put a scientific base on the moon and as a stepping stone to future exploration of the rest of the solar system. And that's going to take a lot of things. One of them is you need a cheap way of doing that. And with our national debt now, somewhere on the order of what, like $39 trillion, it's hard to get folks, if you like, taxpayers to jump on board anything that's going to cost a lot of money. And so in some sense, we are behind the eight ball, even worse than maybe, in the 1970s.
All true, and I don't think nationally we make a really great case for being in space and for taxpayer money being spent on space. The private sector can pretty well do what they want and spend money, how they see fit. But the tax dollar means something, especially when people have issues with the cost of living and other things, more in their face than, say, a trip to the moon. I do think there are reasons to be doing this, and I do think there's reasons for the government to be involved in this, but we don't tell a really great story about it to the public. And even if we did, I'm not sure the media would pick up on a great story, because they seem to tell stories and report stories based on another set of standards. And I'm kind of being polite there, but to get the word out to the American people, and maybe global people, because we do have global partners with Artemis, on the value of this, when we've got wars on, we got people that can't buy medicines, and that food prices are going up all the time, and this and that and the other. You got to make a really strong case for how you're going to spend the taxpayers' money.
Yeah.
It's unfortunate to me, and the space show is 25 years old. I've been looking at the deficit and the interest, since my graduate school days, but almost from the beginning of the space show. And there's this website, and I never can remember the name of it, that tracks our deficit and all the components of it real time. You can watch the numbers changing as you're on the thing. I think it's the real budget or something like that. And I've watched it go from 15 billion or 15 trillion to almost 40. And I would interview different space economists and different people, and they would all say, nah, none of this matters, none of this matters. The space portion of the budget is so little, it doesn't make any difference. Well, of course, that was never true. But now it does make a difference, because a small piece of $40 trillion is a lot of money. And the interest that we're paying is bigger than the War Department's cost for the most part. So why are we spending it on going to the moon? And why do we care that we have to beat China to the moon? And these are questions that should be answered by our members of Congress, but I don't really think I've ever heard a really great answer by anyone out of Congress. They're the ones who appropriated the money and who keep appropriating the money for the project.
Now, David, you can think of back in the late 60s. That wasn't a great time either. Vietnam was going on, and you might ask, why bother going to the moon? In fact, you can hear civil rights leaders back in them days. There was an individual that made a statement just after the Saturn V left the launch pad, stating, and I don't remember his name now, something like, for one fleeting moment, I forgot about all the hungry people on Earth, as he watched with national pride, of course, the Apollo 11 on its way to the moon. So but how many people, how many scientists have you interviewed and said, what got you interested in the space program? What got you interested in aerospace engineering? And if they're of the right age, they would say, oh, it's the space program of the 60s. That's what really got me interested as a young child. So I don't, all the apples are not in one basket, but we could certainly say, what's going to inspire the future generation of people, of young people, right? Get off the iPhone,
And
do this and do that. What are you going to do? Well, going to the moon, and then with the plans, long-term plans of going on to Mars, exploration, and who doesn't want to see what's over the other side of the nearest hill? All these kind of things. Isn't that worth something?
and I'll point out that just because space exploration got them interested in science does not mean that's what they'll go into. I got interested in astronomy by being first interested in paleontology and geology. And here I am studying astronomy and astrophysics instead. So, yeah, and we do have a couple of questions when we get a moment. So,
Yeah, so maybe David, if you can say something about that.
In the early years of the space show, I would ask all of my guests how they got their interest in space. And I think the percentage of people responding to that, talking about the early space program, incentivized them. Apollo, maybe it was Gemini, maybe it was Mercury, something related to the early space program, gave them the push to go do whatever it was necessary to have a career in space, be it physics or engineering or astronomy, or wanting to, do something that would take them on the path of an astronaut or something like that. I've not asked that question anymore because so many people in the space industry now are much younger, and most of them probably that are guests on my show weren't even born during the time we went to the moon. So certainly it may interest them as they study it through history. But we had the Cold War back there. I can't underestimate the impact that had on people. So, for example, I grew up in Tulsa, Oklahoma, and I can't tell you how many duck and cover drills we had in grade school in Tulsa. In case we saw a big bright light and there was going to be a big atomic bomb blast, and this is what we had to do to duck and cover under our desk. And we grew up with that Cold War fear, and who had the bigger arsenal of H bombs and what was going on in the South Pacific, and that's the big H bomb testing range and stuff like that. So to show the world that the U.S. was better and more advanced in doing things for peace rather than the mean Soviet Union doing things for a more belligerent point of view and totalitarian point of view, that was important to all of us. It caused people in my high school in Tulsa to study math and physics and chemistry. And the same thing in junior high. My high school turned out something like 37 National Merit Scholarships a year, and most of that was on the quantitative side. So, and then of course, Vietnam was a game changer for everybody. But we had a unity to do the work necessary to get into space, to build and develop the rockets, and to do it before the Soviet Union, because they were communist and they wanted to do us in, and we all grew up with duck and cover drills. And I mean, we laugh at it now, but if you are a little kid being told if you see a big bright light, duck and cover because this is an atomic bomb going off, and we know what happened in Japan with atomic bombs, you kind of take that seriously because your parents are repeating it, the teachers are repeating it. We had three TV stations at the time. Later on, we got public education in Tulsa, and they were repeating it. That's not our world today. So I think today, to make the case in a world full of distractions and where so many people get their news from social media sites, which is unbelievable to me, you got to go the extra mile to let people know why space is really valuable to us, and I think it is, but I'm not the guy out there in charge of space PR for the national country. And honestly, there are times when I don't know how to reach some of the audience either, that live on the social media sites and some of what they believe and do. Plus, I don't think our government, honestly, I hate to say it because I love being an American, is as trustworthy by the public as it was during the Apollo era up until the Vietnam point. I think there
Right.
were big changes in our willingness to trust and believe the media and the government around the Vietnam point. So that I know that's not the topic of the show today, but I think that's a big turning point in the American public. And I know I lost my Virginic believability of the U.S. always having a big halo shining brightly over its head as a result of Vietnam. So I think space is important and it needs to be valuable, and we need to do it in the best way possible to maximize the benefit and to make sure that the public dollars that we're spending on it count. And building something like the SLS, I mean, it was controversial back when they were building it. Remember, Obama canceled the the program from Mike Griffin in the Bush administration to go to the moon, and the Senate wanted to preserve the big rocket, and so that's how we got the SLS, which is based on infrastructure and architecture from the Saturn and the big shuttle launchers. So in the meantime, SpaceX is doing its thing to build an efficient commercial launcher with reusability, something that the NASA engineers and the government big contractor engineers didn't think would happen. They resisted reusability. And so what do we end up with? We got commercial rockets that are really profitable. They're taking astronauts to the space station. They're doing great things. They're launching some of our satellites, including our national security birds, and they're reusable. And what do we got here? We got a launcher that flies maybe once in 3 years, something like that, 2 years. Costs $4 billion to launch it. They can't keep the crew on standby all the time, so they're not proficient in launching it. It runs on liquid hydrogen, and in cold weather, all of that is prone to valve leaks, seal leaks, things like that. That's what we're seeing for delays because there has been cold weather in Florida. And it can't get to the damn moon. The Saturn V got to the moon. I mean, they used an orbital mechanics maneuver to do so. But this thing, all it can do is go to this, what's called a halo orbit, which is where the gateway is supposed to be built. It's got enough energy to go there. It can't be refueled in orbit. And then the private companies are supposed to build a lunar lander to take the gateway astronauts down to the surface of the moon. And they're behind the eight ball on building the lunar lander. So many of us are not optimistic that we will make the 2028 timeline. So we can talk about that. There is a schedule for us to be with Artemis 3, with our astronauts actually on the surface of the moon in 2028, which would, at least in theory, be in advance of the Chinese getting there. And if you want to go down that road as to why I think that's an important objective, we can do that. But in order to make that 2028 goal, and we're flying humans, don't forget, we need safety, we need testing. I mean, I'm not an engineer, but I can take you through the kind of testing that they're going to have to do to make sure it's safe to put human people on these vehicles and on the human lunar lander. And time's running out. So, we're at the beginning of 2026. So we're about if we count the full year of 2028, because windows to the moon are pretty frequent. You can get there. It's not like going to Mars. Um, you've got a little less than 2.5 years to develop hardware, get it flight operational, test it, human safety, all of that kind of stuff, not just for the big launcher. SpaceX's plan calls for what, 14, 15, 16 refueling flights to be able to get to the gateway. And we have never transferred hypergolic fuels in space before. And there is a huge problem called boil off. And we can describe that for your audience, although if you have a space audience, they know what I'm talking about. None of this has been done. Is it easy to do? Again, I'm not an engineer, but I'm a business guy, and I don't think it's easy to do. I think if it was easy to do, it would have been proposed and done earlier, because again, I wrote about transferring hypergolic fuels in the late 90s in my doctoral dissertation, and I described the boil off problem. So this is not something that has just popped up new because Starship is going to require 14, 15, 16 refueling stops using hypergolic fuels. And so, and then you've got to make sure the damn thing is safe. And how many safety flights are you going to fly, or test flights will you fly before you put a human on it? So NASA is pretty risk-free, as we all know, and I think they will move heaven and earth to make it safe. So that 2028 timeline is questionable. So there are a lot of people in the industry that are proposing Artemis get revamped and made a lot simpler. And Mike Griffin, the former NASA administrator, has a program using 2 launch rockets and doing it a little bit different. His program is all over the web, including on archived space shuttle programs. Other people have advanced ideas on how to strip out all of this stuff, how to get rid of the refueling flights with Starship, how to use, say, the Falcon Heavy in multiple flights, because that's an operational proven vehicle. But it doesn't appear to me that NASA or any of the policymakers are going to change the scope of the mission or the hardware or the methodology. So we have 2.5 years, and Artemis 2 is delaying again, and that success is clearly needed to help Artemis 3 along the way.
Yeah, and
So
I
think Artemis is in trouble.
when you think, David, about Artemis 2 by itself, that's not even repeating. Like some say, oh, it's a repeat of Apollo 8, but it's not, because Apollo 8 went into orbit around the moon.
Yeah,
And-
well, this does a loopity-loop around the moon.
Yeah, it's a free return trajectory, so you're not even demonstrating slowing down to be captured by the moon's gravity, if you like, and then orbiting the moon for a set number of orbits, and then proving that you can get out of lunar orbit and get back to the Earth again.
So, and I didn't even mention the fact that they're flying in an Orion capsule made by Lockheed. So when they flew the Orion capsule as a test to the moon and back, so the velocities coming back from the moon are significantly greater than coming back from low Earth orbit. I mean, magnitudes greater. So they noticed that the heat shield had damage on it when they got it back and inspected it. So there were no astronauts on it. It was a demo flight. But now they've got a heat shield problem on Orion. So they need to create a new heat shield for Orion, but they can't do it in time for Artemis 2. So here's their fix. They're going to change the direction of how the Orion capsule flies back to Earth, so that its angle of attack with the Earth atmosphere and its return speeds are different. And they think that these orbital changes will create less pressure and less heat on the heat shield, and it will be okay. But for Artemis 3, they're going to have a brand new designed heat shield, so they don't have to tamper with the orbit. Okay, how many test flights will Lockheed require to test a brand new heat shield? They're not going to put a brand new heat shield on Orion and put the astronauts in it and fly it the first time. At least I'd be really surprised if they did that. So that's another factor to look into this timeline of 2028. So if we said, can we get back to the moon and do this, and we got to do it, say, by 2030, yeah, I'd say no problem. But 2028 isn't a lot of time to build what does not exist yet and to test it, make it flight safe, flight ready, astronaut safe. I think, and a lot of people think that Artemis might be a little bit in trouble, and I guess we'll find out, because NASA and the government seem hell bent on going through with this program from Artemis 2 and Artemis 3. And if they're delayed again in April, man, I just don't see how they can make a 2028 timeline.
And then you see like reports out of China, and you have to take it with a grain of salt. We don't know exactly what's going on in terms of R&D and development and so on. And they're progressing, right? They're testing their lander. They're testing their first stage of the rocket with the abort system on their capsule, which just came out a couple of weeks ago, photos of that. So they seem to be doing all the things that's necessary that put them in good shape for landing on the moon, potentially in 2030. So with everything going on with the Artemis program, I'd be really surprised if we even get there in 2030 with a lander. Because, obviously there's issues, as you mentioned already. Blue Origin has stopped flying private citizens making money because they have to take all those experts, I assume, off of that project and put them on developing the moon lander because they're behind so much.
Well, a couple of things about China. We don't know all that we would like to know about China, but it's really, in my view, it's sort of an unfair comparison, because this is a communistic, totalitarian, do as I say so, or go to a work camp, or go get killed, or something like that country. And if the leaders of China and the party, the Communist Party, say it's important to go to the moon, they'll bankrupt every other part of the country to put the resources into going to the moon. They don't answer to anybody. There's no accountability. They don't have a Congress with all sorts of crazies in it like we have. Nothing like that. So they can do and spend money and prioritize as they see fit. But we really don't know their progress. We don't know all that I guess we'd like to know for comparison purposes about their human spaceflight program. We have seen samples of it with their own space station, and we did see samples of their safety concern, which I think were impressive, when they got hit by a piece of space debris in their space station a couple of months ago, and it cracked a tiny part of the windshield in the space station. And so they were not, this was in their habitat, not their habitat, but their capsule that the astronauts travel on, taikonauts travel on, to the point where they would not fly that capsule back to Earth with astronauts in it. So they hurried up and sent up a replacement capsule, which was probably pretty close to ready to go, and brought the astronauts back to Earth after a couple of weeks of delay in the replacement capsule. And then they brought the damaged one back, even though they did a spacewalk and repaired it. They brought it back empty to Earth, and it came back just fine and flew just fine. But I thought that was an impressive example of their concern for human safety and of their ability to detect a problem, do a spacewalk and repair it such that it worked, and their ability to have a rescue vehicle up there. Wouldn't we like to have had a rescue vehicle up there for Columbia?
Right.
Or had one on the pad where we could have kept them in orbit, and that was a known fact. We could have kept them in orbit, but all the political decisions that were made by these guys didn't follow up on due diligence. I guess I'll say it that way. And they probably could have done vehicle-to-vehicle transfers in their spacesuit to get them to the new vehicle. So there are major differences, but when you understand that this is a communist totalitarian government that can prioritize and spend as they see fit, and we can't do that, and we don't want to be able to do that. There are big differences, and it gives them some advantages, but it may not give them advantages over American technological development and R&D and other things. Remember, they still steal everybody's tech that they can. They do develop their own. They develop their own artificial intelligence, but they're also ripping stuff off. So I think we wait and see how accurate some of the forecasts are for Chinese access to the moon. They may not make their 2030 timeline, although they have a pretty good track record of making their timelines.
Right. Now, David, long-term exploration of space by humans. It seems like, SLS, some people jokingly call it the Senate launch system because of what you'd mentioned. It doesn't seem like that's the way to go for the United States. That maybe being better to give contracts to private companies so they know they have money that's going to come in from the government to develop the hardware that we need to support that sort of long-term exploration of space. So what I'm hearing is, by the time we get to Artemis 3 or 4, that's going to be it. Like it's probably going to get canceled. I mean, even Barack Obama didn't want, like you mentioned, didn't want to go back to the moon, right? He was thinking about sending astronauts to asteroids, some nearby asteroid or something to do that. And he had the attitude, which a lot of people have, is we've been to the moon, we've done that, let's do something new for our generation. And so you're working against that as well when you throw it all in the mixture.
I believe there's a lot to do, develop research, and keep us busy that is very productive on the moon. So we can talk about that if you want. However, let's talk about the human spaceflight mission in the United States and going to places. So we're using chemical rocket propulsion. And since I've been doing the space show for 25 years and before, people have been shouting, let's get nuclear propulsion. And they actually tried to do it, and it got shut down. But so I see the remnants of the nuclear space engine in the government's National Nuclear Museum in Las Vegas. If you come to Las Vegas, they have a whole room devoted to what was to have been the nuclear rocket. But chemical propulsion can get us to Mars. And because Starship is so big and powerful, it can get us there a little bit quicker than maybe other chemical rockets. But if you really think that humans can go elsewhere and deeper, you're not going to do it with chemical propulsion. So nuclear is the most capable near term, and they've been developing it, I don't know, probably since my entire adult life, and we still don't have it. But the other side to this is, let's look at the human factors of human medicine and being able to live in space or to be on another planet. Because everyone thinks we're just going to go to the moon and live on the moon, and we'll have spacesuits, and we'll shield the structure by pounding regolith on top of where we're living, and radiation won't get to us and all of that. So a couple of factors. We still do not know, nor are we working to know, the gravity prescription for humans in space. So what is the gravity prescription? I mean, this is about as basic as it gets. The moon is 1/6 gravity, and Mars is about 38% of Earth's gravity. Can humans live in 1/6 gravity? Can we live on Mars? Can we have children? Can a baby develop in utero in microgravity? Can kids grow up and be healthy? None of this is known. And can humans survive for any kind of really length of time in these hostile environments? So They have to live in some kind of shelter where they have to go underground somehow. They have to have massive spacesuits that are going to protect them. The lunar soil and the Martian soil is poisonous. It's toxic as hell, and it's toxic to equipment too. And then living in free space, like a mission, if you're going to go to out there, if you don't do something to protect your eyes, to protect, well, name your body organ that you need to protect. You got it. What are you going to do? You're going to exercise 3 hours a day so that when you get to the moon or Mars, you can walk off the space capsule, and because there's not going to be anyone there to carry you off. So there are private groups that do research and work on space medicine, and there's a lot of universities and their medical schools that get contracts. Baylor and the Trish Academy down there with NASA do great work, but lots of this is contracted to the major schools like University of California and Texas and all sorts of stuff. But we really don't know how to live in space and what it will take. And the fact that we can't even get a centrifuge in space to figure out our gravity prescription for humans is mind-blowing. So there's a guy, actually, you ought to see if you can get him to be on your show. It's Dr. Jim Logan. I don't know if you know him or if you've heard of him, but he was the space flight doctor for the astronauts during a good portion of the Apollo program and such, and he's retired now. But he's still very, very active in space medicine. And he used to say on the space show, and he was one of my best teachers ever, that you will know when NASA is serious about humans in space when they figure out the gravity prescription. And until they do that, humans really aren't going to be spending much time outside of low Earth orbit. And he said that, I don't know, dozens of times 25 years ago. And that seems to be the unwritten law today. So we can talk about nuclear propulsion and all this other stuff, but if we don't have the know-how to live and be healthy in space, what kind of diet to eat, how we're going to get food up with people going to Mars for any length of time, or the moon, or are we going to keep supplying food from Earth? Because remember, even if our launches go down to a much cheaper price, they still cost money. So if we're going to resupply everybody on the moon and resupply everyone on Mars from Earth, that's an ongoing huge cost. And for Mars, that's an ongoing logistical problem because of the launch windows to Mars and how much time it takes there. So can you imagine the supply train? It'd be like 1 million covered wagons trying to get supplies out to somebody lost in Death Valley or something like that. We have no plans for that. Being in microgravity for a year on the space station, we know what happens to the body. We know your eyes are going to change. We know all sorts of things are going to happen to you, not just bone loss and not just some of the other issues that occur, cardiac and stuff. We don't have ways to treat it. Our pharmaceuticals deteriorate in microgravity. Some deteriorate faster than others. We can't do surgeries. What if someone on a Mars thing has to have a bypass surgery or something? You can't bring them home, and there's no way to do microgravity surgery in a big way. So if we're going to talk about humans and a human space program going out into space, to me, what's missing is not only the technology to do it, but addressing these issues of how humans can live and prosper and fare well in the space environment. And we're not there. And I hate to say this, but we've progressed a lot academically. We know a lot about these issues. I talk to people all the time that can tell me all about these issues, but there's not one application, not one demo not one test of hardware, nothing to implement any of this for space flight and humans and crew health and longevity. And if you want to live in space and you want to have settlements, you probably at some point have children, right? Do you think bringing guys and girls up there and they're, on the moon in a moon colony or Mars or even an orbital colony, like O'Neill suggested, they're not going to be playing around. Women aren't going to get pregnant. What's going to happen? Can you carry a fetus to term in microgravity? What's going to happen to them? What's their development? Can you get them the nutrition they need? I mean, there's 1,001 questions, all of which relate to humans being able to live in space and go someplace in space, even to Mars. And people, might call me a little bit gloomy, but the space community is really rich in rhetoric. You guys probably know that. The rhetoric is fabulous. I mean, it's better than some of the people in Congress. It's amazing.
And it began back at the beginning with von Braun.
But if you want to dig into it, to make it happen, to bring our visions and our dreams to reality, wasn't there a hot dog commercial or a hamburger commercial about where's the meat or something like that?
Yeah, where's the beef?
Where's the beef?
Where's the beef? Where is the beef? And we're deficient in this. And I don't think the Chinese know anything more than we know. And I don't think Russia does either. The European Space Agency does do a lot of this research, but again, it's on the theoretical and academic side because there's no way for them to bring their academic knowledge and their expertise into practical applications. And if you can't apply it to people going into space, then all you're doing is writing textbooks, right? Or something like that. And I think that's where we are. So yeah, there's a lot of great things that we could do over the long term with humans in space. I mean, it is costly. We could go beyond Mars eventually. We need propulsion, we need technology, but we need survivability. And I don't see that we've gone far enough along it's called human factors, the human factors road to realize this yet. And that's a disappointment to me.
Well, it sounds like, a lot of this, it's kind of would be put to a lesser emphasis by just putting out the robotic missions more so than what we've done already. Not to exclude human, because I'm all for that. It's just that even from the robotics part of things of exploring the solar system, we could have done a lot more than what we've done.
Absolutely.
And
I think robotics are fabulous. So for robotics, I'd sure like to see propulsion dealt with so we can have missions get places a lot faster. We could, if we had really fast propulsion, we could get to, some of these distant locations that have a potential for water and life. At least we think they can from, what we've been talking about, like Europa, for example. So we could get robotics onto Europa long before we could get humans there. But without propulsion that is advanced, I mean, what does it take? 8, 9 years to get to Europa, and the launch window is really rare to go there. So I'd like to see us advance in the technical side, which would be the propulsion side. And I think the robots are great, and the robotic development is super, and it will be cheaper, obviously, than sending humans into space. And we just saw China demonstrate their robots with martial arts dancing. You probably saw the videos of that. But in China's got pretty advanced robotic development too. So I think that'll be part of sending humans into space. But I also still believe that we can't yet replace humans in the loop. And I know that's a big active AI discussion, right?
Yeah.
But I think humans are still play an important role in technology and research and development and exploration. But they can certainly be preceded by and assisted by robots.
It's a wonder why, here at the Advanced Propulsion Division at NASA, as far as I know, it receives little money, compared to a lot of other things that are being supported within NASA itself. And it's like you think that that would be one of the main drivers would be to put money into that to try to develop the engineering to, I mean, for example, how long are we going to have to wait before we send a robot to Proxima Centauri? You're not going to send it now. It's like trying to go to Europe on a rowboat or something. If you make it,
It's worse than that.
yeah, it's worse than that. But still, it's just we got to start somewhere. It's not like you think of Christopher Columbus. He's not going to wait till the 747 comes along to go across the Atlantic, right? He's going to go before that. But where is that point? Up to you get what 20% the speed of light or something like that, and then it makes sense to send first robots. Obviously, they'll go, much.
Yeah, but the 20% speed of light experiments that were being done by Breakthrough, which is shut down right now, were to send a wafer at that speed. I mean, this is like one of the microchips that you have in your cell phone, or a little chip that you would use in your computer, or a memory chip, something that small. Plus the fact there's no way to slow it down. So if you
Yeah.
wanted to actually stop, and how far in advance of getting to Proxima Centauri would you have to start braking to actually be able to get there and slow down? But then once you've dropped your speed way down, it could still be 2, 3, 4, 5, 6 light years out there. I mean, that's a big, big reach. And so Breakthrough wanted to send wafers out there and just have them fly by and send data back through laser light and stuff like that. But that project, I guess, has been shut down. Whether they'll resume it or not, I'm not sure. But I don't think you need speed of light to get to Europa a lot faster. Or we had an asteroid mission that included Ceres, I think is the thing, and there was potential water and stuff there, and people thought about that as being an Earth-like kind of asteroid that should be explored. People talk about 50 kilometers, or we could just say for people's sake, 50 miles up in the clouds of Venus is a real Earth-like sweet spot. But getting to Venus is not so fast and not so easy. And then what's our technology to orbit 50 miles in the clouds of Venus, or to think that we could put people there if it is a sweet spot? We need to learn how to do this, in my opinion. And if I'm talking to people at the line in the supermarket, and they start in with, "Why do you want to spend this money? Look at how expensive my damn steak is," and on and on and on. I've got to be able to give them a really good and attractive explanation. So why spending that money is going to help their lives and the lives of their children and grandchildren. And as I said when we started this show, I think we need a lot of work on that. But I could give it a good try, but a lot of it depends on, honestly, how open-minded the person is.
Right.
To get off of their hostility about their steak costing so much or their coffee costing so much. Because to receive information, you need to have an open input. I mean, you can't send information to something that's closed. I'm not a physicist, but maybe you can answer that question. Can you send information through electricity or electrical charge or something to an entity that is closed off? I don't think it can receive the information.
The other aspect of things too, it's the joke that people always say, if the dinosaurs had a space program, they'd be still here. It could be the survival of humankind that's at risk here by not having a space program. At least one to give it a good shot of trying to, deviate a comet or an asteroid that we get enough notice ahead of time that we could alter its trajectory slightly so it does avoid the Earth.
Or evacuate if a caldera is about to blow.
So all of these
Yeah.
are important in that sense, you would think.
Yes, but they're so far out in the future for most people.
Yeah.
And their problems are so, I should say our problems, not their, because some of these problems affect me too, are so close at hand. Medical problems, for example, different kinds of costs, different other kinds of issues, crime problems, all sorts of things. They're in front of us 24/7. And yeah, someday we might get hit by a big rock. Well, that is so far out there, I can't internalize that when my needs are right in front of me and slamming me every day 24/7. So I agree with you. I think planetary defense is crucial, and spending money on it to improve how we do it, to detect the objects and all that, I think is really crucial. But that's a harder sell to people who are staring down the problems of the modern world. And they have a family, they have kids.
Now, David, I remember back like the 1980s or so when the International Space Station, before that, was what, Alpha or something they called it, that it was going to be,
Space Station Alpha,
that it was going to be just at first just an American space station, and it had come very close to being canceled several times, and I think it was up against the superconducting super collider during Clinton administration, if I'm not mistaken. It was go for the International Space Station or go for the other one, and they ended up canceling, of course, the particle collider. Now, the talk then, when you had advocates who supported the space program, they would go around talking to people saying, for every dollar that NASA or that the United States government spends for NASA or gives NASA, we get $7 or so in return. Number one, was that really true? And number two, what is it like today, compared to the 80s?
So that number varies, anywhere from maybe $3 to $6 or $7 per dollar. But yeah, I think it is true, but it certainly depends on what the project is that you're looking at. So if we take the space station, and they have a lab on that space station. It's a national lab. It's no different than the national labs in New Mexico and elsewhere. And we take the pharmaceutical industry. So pharma is using the development of drugs in microgravity, and there's a reason they're doing that. And also hospital researchers like Cedars-Sinai in Los Angeles, and they're printing artificial tissue for hearts. They're printing 3D knees for knee repair, trying to do this because the return on the drugs that they've already created, like Keytruda for cancer, is just pharmaceutically beyond imagination. So therefore, the money that the U.S. government spends to make that national lab available and to maintain it and to train the astronauts to work the lab, because Cedars-Sinai isn't sending anyone up there for them to work on it, is producing results. And yes, it goes into the private sector, but the private sector hires people, they sell people, they get taxes. It's the flow of money. So it comes back. So those are huge, huge returns. But if you're talking about something that is a very basic research project, for example, there are companies that are trying to 3D print living structures on the moon. So they're spending an awful lot of money to come up with simulants, because there are lunar simulants that we have on Earth that are manufactured that can simulate lunar regolith, and trying to perfect it. But of course, they need to get to the moon to really perfect it. So this is basic research, and as you probably know from your physics work, that basic research probably in the best of worlds leads to profitable research down the road. But one of the reasons why the government invests in basic research is that it's hard for private sector companies to invest in research that doesn't show up on the bottom line. So for the government to make available basic research opportunities in space can do nothing but help all the people on Earth. So the cancer drug Keytruda is not only sold to Americans that have the kind of cancer that it treats, it's a worldwide cancer drug changer. There are other drugs. I mentioned earlier that my son, who has cystic fibrosis, they flew that gene in space, and the government did that. And what they learned from doing that led to pharma's development of drugs that have absolutely turned CF in many, many cases from being fatal to a lifelong illness that you can live with. That happened because of space. And there are countless other examples of this. There are countless examples of what they're doing with crops to grow in space that have direct exchanges with doing agriculture here on Earth. So, but I guess it's harder to make these points to people when the problems of life and our daily culture are in their face every day, and the news media is amplifying it every day. And you hear your elected representatives talking about it all every day. And then we're saying, here's the vision for space, and here's how it can change your life. And they're not feeling it. Right. They're not experiencing it. So there is this disconnect. But there is this very important role for government, for our government, especially our government, because it's a free government, to explore and develop space. And this is the bright part of what I'm talking about. Thank God they're doing it. For the most part, it's bipartisan. So for the most part, it doesn't get caught up in all the policy and political crap that so much else gets caught up with these days. And it's vital to all of us, whether we know about it or can see it or not.
Yeah.
Yeah. You ever ridden in an ambulance with high-tech comms transmitting all sorts of information to the ER, and you're 20 minutes out, and you've got the ER doctor capable of directing the paramedics what to do to keep you alive until you get there. That technology is from space.
Yeah.
Yeah.
So I don't know what to say. I could make the space is so vital to our future and to humanity, and I hope we don't lose sight of that.
Yeah, definitely the spin-offs and the potential, of course, are extremely important. But we've run out of time for this podcast. I would just like to say thank you very much, David, for AKA Dr. Space, for being on our podcast this evening. And if any of you listening out there, especially high school students, if you're wondering what to do with your life, go to higher education, learn how to become an engineer, get involved in the space program. Maybe you'll be one of the ones that will work on this advanced propulsion that'll get us to Mars a lot sooner than what we can do nowadays with nuclear rockets or whatever the next technology is that would come along after that. And we do have programs here at the University of North Dakota, both online and on campus. So we have lots of programs in STEAM, not only in STEM, but also in the arts. Of course, we need people to communicate these things for others who are non-scientists. Now, our next podcast will be next Tuesday on March the 3rd at 5 p.m. Central Time. We always leave you with a quote at the end of our podcast. This one is somebody that David had mentioned already, Gerard O'Neill. And so the quote is this: "It is the hope of those who work toward the breakout from planet Earth that the establishment of permanent, self-sustaining colonies of humans off Earth will make human life forever unkillable, removing it from the endangered species list, where it now stands on a fragile Earth overarmed with nuclear weapons. Second, the opening of virtually unlimited new land areas in space will reduce territorial pressures and therefore diminish warfare on Earth itself.
Don't know about that, but it's a good dream.
It's a good one. Anyways, thank you very much for listening to this podcast. And thank you, David, for being here. If you want to say your goodbyes, go ahead. And we'll see you next time. Thank you.
Okay, and I want to thank you all. And I sincerely believe that despite our problems, the path to a better world and a better humanity for everybody is to go through space. And I just hope that the policymakers and decision makers and the people that are able to implement activities to facilitate that really understand that to their very, very core, because space is, in my opinion, the savior of our humanity and our world, and it's much bigger than each of us, and we need to learn how to use it, make it our friend, and live in it.
Thank you, Dave.
Thank you.
Goodbye, folks.
Thank
Bye,
you
folks.
very much.